Today's experiment, the specific heat of a liquid by using Newton's law of cooling method. The aim of the experiment is conduct an experiment to determine the specific heat of a given liquid by using the principle of Newton's law of cooling. Apparatus. The required apparatus are the calorimeter, stop clock, weighing machine, retort stand, thermometer, water and a liquid whose specific heat we want to determine. That may be an oil, glycerin or any other liquid form. Right. Principle. According to the principle of Newton's law of cooling, the rate of cooling of a hot body is directly proportional to the temperature difference between the hot body and the surroundings. Formula. The specific heat capacity of the given liquid is given by S is equal to m1s1 plus m2 minus m1 into s2 by m3 minus m1 into t2 by t1 minus of m1s1 by m3 minus m1 calorie per gram per degree centigrade. Here, the specific heat capacity of an unknown liquid, that is oil or glycerin, is measured based on the specific heat capacity of a known liquid. Here, the known liquid we are considering it as water. That is, we know the specific heat of water, that is S2 here is equal to 1 calorie per gram per degree centigrade. So, if you go to the formula now, the terms in the formula are M1 is the mass of the empty calorimeter in grams. So, this is the empty calorimeter, and the mass of this empty calorimeter can be measured by using this weighing machine. I can observe here it to be 32.11 grams. This is the mass of this empty calorimeter. And M2 refers to mass of the calorimeter plus water included in it. You can see this calorimeter is filled inside by using water whose specific heat value we know. So, mass of this water plus calorimeter combined is M2. That is measured to be about 86.89 grams. Right. Here next M3 here refers to the mass of the calorimeter plus liquid, that is unknown liquid whose specific heat we want to measure, that is M3, the mass of the calorimeter plus filled with unknown liquid. Here this is the unknown liquid, I am using here an oil. So, the mass of the calorimeter plus oil combined is 81.47 grams. And S is a specific heat capacity of the calorimeter. All the calorimeters here I am exhibiting are all made of brass. So, the specific heat of the calorimeter here S1 is equal to 0.09 calorie per gram per degree centigrade. Here you have to fill the value of 0.09 calorie per gram per degree centigrade. So, because the calorimeters are made of brass. And T1 in the formula here refers to the cooling time for water. That is, cooling time for water is T1 seconds, and the T2 refers to the cooling time for liquid in seconds. Make sure that the water which is filled in the calorimeter and oil which is filled in another calorimeter should be at the same level. Now, initially take the calorimeter containing oil and insert it in a thermal insulation chamber. Close this chamber with a lid, and now insert the thermometer and a stirrer inside it. Now, switch on the steam generator and the water present inside the steam generator starts to boil, and once the water vaporizes inside the steam chamber, this hot steam is now passed through the inlet into the calorimeter, due to which the temperature of the calorimeter will gradually increase. Once the temperature here attains a value of around 80 degrees centigrade, switch off this steam chamber. After some time, the temperature inside this calorimeter will gradually decrease from 80 degrees centigrade. Now, when the temperature here is about 80 degrees centigrade during cooling cycle, switch on this stop clock and record the time required for the temperature to drop at some specific intervals. Here the interval we are considering is 2 degrees centigrade. That means you have to measure what is the time required for oil to cool from 80 degrees centigrade to 78 degrees centigrade. We have to measure what is the time taken. This can be done by using a stop clock, and that time is recorded over here. is initially at 0 seconds at the starting of the observation, the temperature of water or the temperature of the liquid is 80 degrees centigrade. Later on, for the temperature to attain 78, what is the time required? You have to write it over here. And later again measure what is the time taken for the oil to cool to 76 degrees centigrade, and later first time required for it to cool to 74 degrees centigrade until the temperature of oil becomes 60 degrees centigrade. Record all the observations here. So please make sure that the temperature, the drop in temperature of the oil is recorded at an interval of 2 degrees centigrade starting from 80 degrees to 60 degrees. You have to measure and record the observations over here. Similarly, record the same observations, that is the time taken even for cooling of water also. That is even the calorimeter containing water is placed now inside this thermal insulation chamber, and then hot steam is passed until the temperature of the water is going to attain 80 degrees centigrade, and afterwards the steam chamber is switched off. Now the water is again similarly allowed to cool within from temperature of 80 degrees centigrade to 60 degrees centigrade at an equal intervals of 2 degrees centigrade. So we have to measure what is the time taken for water to cool from 80 to 78, and what is the time taken for it to cool from 78 to 76, and so on up to 60 to 60. We have to measure just we have done for liquid, and we have to present the observations here. Now the model graph. Here we can see that cooling curves are plotted for water and liquid. We can see that water has a higher specific heat and thereby requires more amount of time to cool from higher value of 80 degrees centigrade to a value of 60 degrees centigrade. Whereas liquid, any other liquid, oil or glycerin, what we consider, always possess a specific heat lower than water. That is why they require an lesser time to cool from the value of 80 to any other value. Now plot the cooling curves here for both for water and for liquid independently on the same graph. Now from this cooling curves, take any two temperatures randomly you can consider. On the graph the two temperatures are shown to be as 70 and 65. We have taken two temperatures 70 and 65. So you have to measure what is the time taken for water to cool from 70 degrees centigrade to 65 degrees centigrade. What is the time taken for that? That is measured as T1. And similarly for oil to cool from 70 to 65 degrees centigrade, what is the time taken? You have to measure it. We can see how we can do. Draw a horizontal line from 70 degrees centigrade. We can see that this line cuts the curve at a point here for liquid, and for temperature 65 degrees centigrade, the horizontal line cuts the curve at this point. So these two, the difference between these two positions on the x-axis gives the time taken for oil to cool from 70 to 65, and similarly for water also the time taken is T1 seconds to cool it from 70 to 65 degrees centigrade. Now coming to the formula, I have recorded here what is the mass of the empty calorimeter M1, mass of the calorimeter plus water included, that is 86.7 grams, and mass of the calorimeter plus liquid included, that is oil or glycerin, that is 81.48 grams included over here, and specific heat capacity of the material of the calorimeter, that is 0.09 calorie per gram degree centigrade. Now here specific heat of water is now 1 calorie per gram per degree centigrade is specific heat of water. And now from the graph you have to measure what is the cooling times T1, that is for water, and cooling time for liquid, that is T2. And substituting all these values in this formula, we are going to measure what is the specific heat value of the given unknown liquid. The first precaution is the water and liquid inside the calorimeters must be filled up to the same level. That is the first fundamental precaution we have to take. And other precautions include the initial temperature of the warm liquid must be well below its boiling point. That is, we have to make sure that either liquid or water should not be vaporized during the heating process. So no liquid or oil should be vaporized. That is why temperatures what we are considering are lying only in the range of 80 to 60. Because we know the boiling point of water is 100 degrees centigrade. That is why we are considering the measurements only in between 80 degrees centigrade to 60 degrees centigrade, both for water as well as oil. That's it. Another important thing is the temperature should be recorded, must be measured very carefully during the thermometer by using a thermometer without any parallax errors. And the surrounding temperature, another important one is the surrounding temperature should not be changed throughout the experiment. Because if surrounding temperature changes, automatically the rate of cooling of the liquid or rate of cooling of the water will change suddenly. Therefore, surrounding temperature should be maintained as a constant. And finally, we are going to, after calculation, we are going to present the result, that is specific heat of the given liquid. The unknown liquid is written over here, either oil or what kind of oil or glycerin, whatever you say, is observed to be the so and so value of calorie per gram per degree centigrade. Now these are the standard values of the specific heats of some liquids. You can see it for glycerin, the value is standard value is 0.58 calorie per gram per degree centigrade, and for mustard oil it is about 0.5. Turpentine oil it is about 0.42, olive oil 0.47, coconut oil is 0.49, you can see it over here, and petroleum products you can see the specific heat is around 0.1 calorie per gram per degree centigrade. You can see it is very low value.